Welcome, learners. My name is Geoffrey Omondi. We've been looking at probability. Now, in the last class, we were able to look at probability space, or what we called sample space. And other than sample space, let me just write that. Probability like that. So we were talking of last class, we were able to look at what we call sample space. And still we were able to look at what we call theoretical probability. Theoretical probability. Now, today, I want us to look at, in this class, I want us to look at probability of combined events. Probability of combined events. And in looking at probability of combined events, we are going to look at probability of mutually exclusive events. We are going to look at probability of mutually exclusive events. And at the same time, we are going to look at probability of independent events. So we are also going to look at probability of independent events. So these are the two things we are going to look at in this class: probability of mutually exclusive events and probability of independent events. Now, in this instance, therefore, it means that we are going to look at probability of two or more events taking place at the same time. So let us start with probability of mutually exclusive events. Probability of mutually exclusive events. Now, I want us to consider a coin. Now, when you look at a coin, when a coin is tossed, when you toss a coin, then there are two possible outcomes. One, the first case is that you end up with an head. That is first case. Second case is that you end up with a tail. The order doesn't matter. You can either end up with a tail or you can end up with a head. So the sample space are only two. It's head or tail. Now, in this case, when you throw a coin, for instance, you cannot have a head and a tail at the same time. You must have a head or a tail. You can only have a head or a tail. So consider a coin tossed once. So we are saying that if you toss a coin once, either you are only going to have a head or you are going to have a tail. Now, these events that you cannot have two happening at the same time is what we call mutually exclusive events. So mutually exclusive events are events that cannot occur at the same time. It is either one or the other. In that case, it could also be others. So we are saying that in these events, only one thing happens or the other. For example, probability, let us look at another case, probability that Miss X dies tomorrow. Now, when you look at this, there are only two things. Either Miss X will be alive or Miss X will be dead. And we cannot have Miss X being alive and dead at the same time. So, in this kind, this is another example of a mutually exclusive event. Now, you are watching this video. So, a student is watching this video. Now, there's no probability that you are not here watching. So, the chance or probability that you are watching or not watching are mutually exclusive. You cannot watch and at the same time watch. You cannot say you are watching and you are not watching. So when you look at that, that is what we are calling mutually exclusive events. And the probability of mutually exclusive events, I can clean here to believe you are through with this. For instance, in the case of coin, we can say that you will either get a head or a tail. So normally this is read as the probability of tail or probability of head. Now, in probability, when you're talking of mutually exclusive events and you're using this word or, when you actually have the probabilities, for example, the probability of a tail here is 1 out of 2 chances. This or is normally called plus. So when you're dealing with probabilities, and this is very important, it is important to note that way. So this or, let me write it properly, or. We can substitute it with plus when we are dealing with probabilities. So plus, probability of having a head is also 1 chance out of the second. So the probability of having a head or a tail, therefore, will be a half plus a half, which is 1. Now, you remember when we were starting to deal with probabilities, we said that if your probability is 1, it means that is a certain chance. And it is true. If you throw a coin, chance that you'll get a head or a tail is certain because you must get one of them. So that is what we are saying. Now, let us look at another situation. If the probability that it rains on Tuesday in Nairobi is 1 over 3. If the probability it rains in Nairobi is 1 over 3, find the probability that it does not rain in Nairobi. Now, you'll therefore say that let us use rains, let us use R, and the probability rain, not rain, let us use R not, like that. So we are saying that from what we have now, here, the probability that it rains or the probability that it does not rain is actually 1, like that. But we know the probability that it rains. So probability that it rains here is 1/3. Or we said that this is written as plus probability that it does not rain, giving us 1 that way. So collecting like terms, therefore, we can say that probability that it does not rain, therefore, is 1. So we can take 1/3 the other side as negative, minus 1/3, giving us, therefore, that the probability that it does not rain is actually 1 minus 1/3, which is 2/3, like that. So that is something we can do. So those are mutually exclusive events. I want us to look at an example from our KLB book here. I want us to look at an example. Let us see one of the examples here. Let us see one of the examples here. So let us see an example. It is a long example, but we'll do it together. So this example is, this is example. A die, we say that a die is singular form of dice. So a die is thrown once. A die is thrown once. A die is thrown once. Find the probability. Find the probability of, find the probability of getting A, an even number or a 3. A, an even number or a 3. B, an odd number, or a 4, C, 3 or less, 3 or less. D, at most 3, at most 3. E, at least 5, at least 5. F, 4 or more, 4 or more. G, not more than 2, not more than 2. So that is the work we have to deal with. So a die is thrown once. Find the probability of getting an even number or a 3, an odd number or a 4, 3 or less, at most 3, at least 5, 4 or more, and then not more than 2. So I want us to start by working on that in this place. Now, it is important to know, first of all, what a die is when you're dealing with these questions of probability. Be keen to ask yourself, what is a die? How does it look like? When you're talking of a coin, be keen to know the properties you are looking for. So in this case, we know that a die has a face with 1 dot, another one with 2, another one with 3, another one with 4, another with 5, and another one with 6. So this is our sample space. This is our probability space when we are talking of a die. So in situation 1, an even number or a 3. An even number or a 3. Now, we have to see from our sample space what are the even numbers. The even number is 2, 4, 6. But what is an even number? An even number is a number that can be divided by 2 without a remainder. Recall. I know some of us could have forgotten. Recall. An even number is a number that can be divided by 2 without a remainder. Good. So with that, we know that we have 1, 2, and 3. So an even number, therefore, would means that we need the probability of getting a 2 or the probability of getting a 4 or the probability of getting a 6. Those are the even numbers. But we are also told we need the probability of getting a 3. So we can add that, or the probability of getting a 3. Let me clean here. Now, looked at keenly from here, we know that in our sample space we have 6 items. So each one of them is actually 1 out of 6. So for example, for us to get a 2 is 1 over 6. For us to get a 4, it's 1 over 6. For us to get a 3 is 1. For us to get a 6 is 1 out of the total number, which is 6. For us to get a 3, it's just 1 out of the total number, 6. So in this case, I want us to continue by saying that we'll therefore say we have probability of getting a 2, or we agreed in probability or is normally given by a plus the probability of getting a 4, or which we give by a plus the probability of getting a 6, or given by a plus the probability of getting a 3. So in this situation, therefore, we'll start adding each one of them one by one. So this will give us the probability of getting a 2 from what we have is 1 chance out of the total chances 6, plus this is 1 out of the total 6, plus 1 out of total 6, plus 1 out of total 6. So we will now have a 6th plus a 6th plus a 6th plus a 6th. So when, and I want us to know this, when we have the denominator being the same for a range of fractions we are adding, normally we simply write that denominator and add the numerators only. So in this case, it will be 1 plus 1 plus 1 plus 1 giving us 4. You realize this is not a fraction in its simplest form. So we can simplify this by dividing both numerator and denominator by 2 to get what we call 2 out of 3. Good. Now, because we've done the first one, we can now move a little bit fast when we're dealing with second, third, fourth, fifth, sixth. So number B, probability of getting an odd number or a 4. So when you look at our sample space here, the odd number is 3 and 5. So it means we are looking at probability of 3 or the probability of 5 or the probability of getting a 4. Probability of a 4. So in this case again, each one of them has a probability of 1 out of 6 or is plus 1 over 6 or is plus 1 over 6. This gives us 3 over 6, which is actually a half. So we can move and get C. In this case, this is the probability of 3 or less, meaning we are looking at the probability of 3 or the probability of 2 or the probability of 3 of 2 or probability of 1. So that is 3 or less. So again, probability of 3 is a sixth or is plus, probability of 2 is a sixth or is plus, probability of 1 is a sixth. I want us to believe we now know why we are saying each one is a sixth, because we are only taking 1 out of the total number 6. So in this case, again, when we add, we get 3 out of 6, which is actually a half. At most 3. At most 3. So when you're talking of at most 3, it means we are talking of probability of 1 plus or probability of 2 or probability of 3. So when you look at this, you realize it's the same as probability of 3 or less. So the working will be the same. This will be a half, just like what we have there. In E, at least 5. At least 5. So the next one, E, at least 5. At least 5. So that would mean we are talking of the probability of 5 or more. So that would be, therefore, the probability of 5 or the probability of 6. So in this instance, therefore, we can say that to get a 5, it is 1 out of the total 6 or is plus, and to get a 6, it is 1 out of the total again 6. So that is 1 over 6. So this will give you 2 out of 6, which you can simplify by dividing by 2 across to get a third. Now, learners, I expect you that you work on number F and also work on number G during your free time so that you can see how to work that out when you're dealing with examples related with a die. Otherwise, I want to give us another assignment which you can work on later. I want to give us an assignment which you can work on later. I want us to give us an assignment which we can work on later. I want us to give us an assignment which we can work on later. So let's clean here so that we are able to see. So you can work on this assignment. A bag contains 2 white pencils. Bag contains 2 white pencils and 3 blue pencils. A girl picks a pencil at random from this bag. What is the probability that a pencil picked is A, white, B, blue? So work on this, viewers, and please be free. When you have a comment or you have a question, there's that comment section just below the video you are viewing now. You can comment, tell us where your problem is. We will try as much as possible to respond promptly. I want again to say thank you. My name is Geoffrey Omondi. We'll be meeting in the next class. You realize we wanted to work also on independent events, but you should notice that what we have done, we want to give you time to synthesize it so that it makes more sense to you. So please, if you'd forgive me, we will work on independent events in the next class. I want to say thank you, bye, and God bless you.